So dear students, in this video we are going to discuss a new topic, and that is Ohm's law. And I hope you are well aware of this topic because this is the basics of electricity. I think you have already done this section in your previous class, that is class 10. So Ohm's law is basically a relationship between potential difference across a wire and the current flowing through the wire itself, or a conductor. Suppose you have a conductor and I is the current flowing through the conductor and R is the resistance of this particular conductor, and if V is the potential difference across this conductor, then according to Ohm's law, V will be potential difference will be directly proportional to the current flowing through the conductor. And this will give me, if I change this proportionality into equals to, so it will give me a new constant of the equation, which is known as electrical resistance, which is indicated by capital R. So capital R is your electrical resistance. So V is equals to Ri. This particular law is known as Ohm's law. So we'll discuss some of the few things about this particular law. Now let us do one thing, that is, suppose you have a conductor of length A and area of cross section A, and let us take I is the current flowing through it and V is the potential across this conductor, and let us take R1 as the resistance of this conductor. And according to Ohm's law, V is equals to IR1. So I have indicated resistance by R1. Now first point, what if I double the length of this conductor? What if I double the length of this conductor? So this is your conductor, this was your conductor of length L, area of cross section A. Now you double the length of this conductor. What will happen? Now the current flowing through it will remain the same, because you have just elongated this particular, not elongated actually, you have just put another same conductor in series with it, so the current flowing through it will remain the same. If I was the current flowing initially, the current flowing will remain I itself, but the potential difference across each section will become V now. That means the total potential difference across this twice length of wire becomes 2V. Now then our new Ohm's law becomes 2V is equals to IR1, or simply R1 becomes 2V by I, but V by I is our R1 because R1 is V by I from above equation. So V by I is nothing but it is R1. Okay, sorry. This R is the 2V is equals to IR. R is the new resistance of the whole wire, the total wire, because the total potential difference across this total wire is 2V. So R is the, and I current flowing through this twice of length of the wire is I itself. That means this R is the new resistance of the whole total twice length of the wire. So this R becomes your total resistance of this wire whose length is doubled will become R is equals to, now V by I is the resistance of single wire of length L. V by I is R1, so twice of R1. That means if you double the length of the wire, then the resistance of the wire seems to be double, which indicates the resistance of the wire will be directly proportional to the length of the wire, because on doubling the length, the resistance seems to be doubled. So resistance is directly proportional to the length of the wire. So number 2, half the area of cross section. So what we are going to do here is I'm going to half the area of the cross section. So initial my conductor was this one of length L and area of cross section was A total, but I'll halve it. That means I'll divide this particular wire into two wires of area of cross section A by 2 each. Now what will happen? Since length is not changed, potential difference will remain the same, but now the current will divide into, if I was a current flowing through total length L of area of cross section A, now the current flowing through each of the half will be I by 2. The current will redistribute itself. Current flowing through this area of cross section A by 2 will be I by 2, and this A by 2 will be I by 2, so as that total current flowing through the total length or total area of cross section is I itself. Now if I take this one of the half where the potential difference is V and whose resistance I am going to calculate, and whose area of cross section is A by 2, or the current flowing through it is I by 2, so R I by 2. That means R will be your twice of V by I. Now V by I is nothing but your resistance of the full length, full area of cross section. The total resistance of the full area of cross section is R1. That means your R will be equals to twice of R1. So what happened here? You half the area of the cross section, but your resistance still seems to doubled. That means resistance will be inversely proportional to the area of the cross section of the wire, because you half the cross section of the wire, but the resistance still seems to doubled. So resistance is inversely proportional to the area. So that will give me R is directly proportional to the length and R is directly inversely proportional to the cross section area. So this will give me a new relationship of the resistance, which is rho L by A. So rho is your proportionality constant of the equation, which is known as the resistivity of the given wire, which is a microscopic property. This is a microscopic property of the wire, which we are going to do in detail in our next section. So your Ohm's law, new Ohm's law is your V is equals to I. In place of R, I can write rho L by A. But I by A is nothing but it is the J, current density, small j, which is known as current density. So this is a new definition. So current density is J, which is current flowing per unit area, which is current flowing per unit area. So I'm defining a new property, that is current density. J is equals to I by A, current flowing per unit area. So replace I by A by J, so your V becomes J rho L. So I replace I by A by J. Now V is nothing. This potential difference can be written as electric field into the length of the wire, which we have already did in our second chapter. So J rho L, so L get cancelled. So E is equals to J rho is your new equation. You can write this as E is equals to, or J is equals to E by rho. So rho on this side. So J will be equals to 1 by rho can be written as sigma. So sigma into E, where sigma is 1 by rho. Rho is our resistivity and this sigma is our conductivity of the wire. So J is equals to sigma is your new form of the Ohm's law. This is known as another form of the Ohm's law. This is also the another form of the Ohm's law. So this is it in our this section. So we are going to do in our next section the all the topics. Thank you.